हेलो एवरीवन, वेलकम बैक टू माय चैनल। तो आज हम देखेंगे एनसीईआरटी ज्योग्राफी क्लास 12, जिसका हम देखेंगे चैप्टर 6 जो कि है वाटर रिसोर्सेज। तो शुरू करते हैं हमारा आज का चैप्टर। डू यू थिंक दैट व्हाट एक्सिस्ट टुडे विल कंटिन्यू टू बी सो और द फ्यूचर इज गोइंग टू बी डिफरेंट इन सम रेस्पेक्ट्स? It can be said with some certainty that the societies will witness demographic transition, geographical shift of population, technological advancement, degradation of environment, and water scarcity. Water scarcity is possibly to pose the greatest challenge on account of its increased demand, coupled with shrinking supplies due to overutilization and pollution. Water is a cyclic resource with abundant supplies on the globe. Approximately 71% of the Earth's surface is covered with it, but fresh water constitutes only about 3% of the total water. In fact, a very small proportion of the fresh water is effectively available for human use. The availability of fresh water varies over space and time. The tensions and disputes on sharing and control of this scarce resource are becoming contested issues among communities, regions, and states. The assessment, efficient use, and conservation of water therefore becomes necessary to ensure development. In this chapter, we shall discuss water resources in India, its geographical distribution, sectoral utilization, and methods of its conservation and management. Water resources of India. India accounts for about 2.45% of world surface area, 4% of the world's water resources, and about 16% of world's population. The total water available from precipitation in the country in a year is about 4,000 cubic kilometers. The availability from surface water and replenishable groundwater is 1,869 cubic kilometers. Out of this, only 60% can be put to beneficial uses. Thus, the total utilizable water resource in the country is only 1,122 cubic kilometers. Surface water resources. There are four major sources of surface water. These are rivers, lakes, ponds, and tanks. In the country, there are about 10,360 rivers and their tributaries longer than 1.6 km each. This mean annual flow in all the river basins in India is estimated to be 1,869 cubic kilometers. However, due to topographical, hydrological, and other constraints, only about 6,690 cubic kilometers, 32% of the available surface water, can be utilized. Water flow in a river depends on size of its catchment area or river basin and rainfall within its catchment area. You have studied in your class 11 textbook India Physical Environment that precipitation in India has very high spatial variation and it is mainly concentrated in monsoon season. You also have studied in the textbook that some of the rivers in the country like the Ganga, the Brahmaputra and the Indus have huge catchment areas. Given that precipitation is relatively high in the catchment areas of the Ganga, the Brahmaputra and the Barak rivers, these rivers, although account for only about one-third of the total area in the country, have 60% of the total surface water resources. Much of the annual water flow in South Indian rivers like the Godavari, the Krishna and the Kaveri has been harnessed, but it is yet to be done in the Brahmaputra and the Ganga basins. Groundwater resources. The total replenishable groundwater resources in the country are about 432 cubic kilometers. Table 6.1 shows that the Ganga and the Brahmaputra basins have about 46% of the total replenishable groundwater resources. The level of groundwater utilization is relatively high in the river basins lying in the northwestern regions and parts of South India. The groundwater utilization is very high in the states of Punjab, Haryana, Rajasthan, and Tamil Nadu. However, there are states like Chhattisgarh, Odisha, Kerala, etc., which utilize only a small proportion of their groundwater potentials. States like Gujarat, Uttar Pradesh, Bihar, Tripura, and Maharashtra are utilizing their groundwater resources at a moderate rate. If the present trend continues, the demands for water would need the supplies, and such situation will be detrimental to development and can cause social upheaval and disruptions. Lagoons and backwaters. India has a vast coastline and the coast is very indented in some states. Due to this, a number of lagoons and lakes have formed. The states like Kerala, Odisha, and West Bengal have vast surface water resources in these lagoons and lakes. Although water is generally brackish in these water bodies, it is used for fishing and irrigating certain varieties of paddy crops, coconut, etc. Water demand and utilization. India has traditionally been an agrarian economy, and about two-thirds of its population have been dependent on agriculture. Hence, development of irrigation to increase agricultural production has been assigned a very high priority in the five-year plans, and multipurpose river valleys projects like the Bhakra Nangal, Hirakud, Damodar Valley, Nagarjun Sagar, Indira Gandhi Canal project, etc. have been taken up. In fact, India's water demand at present is dominated by irrigational needs. As shown in figure 6.2 and 6.3, agriculture accounts for most of the surface and groundwater utilization. It accounts for 89% of the surface water and 92% of the groundwater utilization, while the share of industrial sector is limited to 2% of the surface water utilization and 5% of the groundwater. The share of domestic sector is higher, 9% in surface water utilization as compared to groundwater. The share of agricultural sector in total water utilization is much higher than other sectors. However, in future with development, the shares of industrial and domestic sectors in the country are likely to increase. Demand of water for irrigation. In agriculture, water is mainly used for irrigation. Irrigation is needed because of spatio-temporal variability in rainfall in the country. The large tracts of the country are deficient in rainfall and are drought prone. Northwestern India and Deccan Plateau constitute such areas. Winter and summer seasons are more or less dry in most part of the country. Hence, it is difficult to practice agriculture without assured irrigation during dry season. Even in the areas of ample rainfall like West Bengal and Bihar, breaks in monsoon or its failure creates dry spells detrimental for agriculture. Water need of certain crops also make irrigation necessary. For instance, water requirement of rice, sugarcane, jute, etc. is very high, which can be met only through irrigation. Provision of irrigation makes multiple cropping possible. It has also been found that irrigated lands have higher agricultural productivity than unirrigated land. Further, the high-yielding variety of crops need regular moisture supply, which is made possible only by a developed irrigation system. In fact, this is why the Green Revolution strategy of agriculture development in the country has largely been successful in Punjab, Haryana, and Western Uttar Pradesh. In Punjab, Haryana, and Western Uttar Pradesh, more than 85% of their net sown area is under irrigation. Wheat and rice are grown mainly with the help of irrigation in these states. Of the total net irrigated area, 76.1% in Punjab and 51.3% in Haryana are irrigated through wells and tube wells. This shows that these states utilize large proportion of their groundwater potential, which has resulted in groundwater depletion in these states. The share of area irrigated through wells and tube wells is also very high in the states given in table 6.2. The overuse of groundwater resources has led to decline in groundwater table in these states. In fact, overwithdrawals in some states like Rajasthan and Maharashtra has increased fluoride concentration in groundwater, and this practice has led to increase in the concentration of arsenic in parts of West Bengal and Bihar. Emerging water problems. The per capita availability of water is dwindling day by day due to increase in population. The available water resources are also getting polluted with industrial, agricultural, and domestic effluents, and this in turn is further limiting the availability of usable water resources. Deterioration of water quality. Water quality refers to purity of water or water without unwanted foreign substances. Water gets polluted by foreign matters such as microorganisms, chemicals, industrial, and other waste. Such matters deteriorate the quality of water and render it unfit for human use. When toxic substances enter lakes, streams, rivers, and oceans and other water bodies, they get dissolved or lie suspended in water. This results in pollution of water, whereby quality of water deteriorates, affecting aquatic systems. Sometimes these pollutants also seep down and pollute groundwater. The Ganga and the Yamuna are the two highly polluted rivers in the country. Water conservation and management. Since there is a declining availability of fresh water and increasing demand, the need has arisen to conserve and effectively manage this precious life-giving resource for sustainable development. Given that water availability from sea or ocean due to high cost of desalination is considered negligible, India has to take quick steps to make effective policies and laws and adopt effective measures for its conservation. Besides developing water saving technologies and methods, attempts are also to be made to prevent the pollution. There is need to encourage watershed development, rainwater harvesting, water recycling and reuse, and constructive use of water for sustaining water supply in long run. Prevention of water pollution. Available water resources are degrading rapidly. The major rivers of the country generally retain better water quality in less densely populated upper stretches in hilly areas. In plains, river water is used intensively for irrigation, drinking, domestic and industrial purposes. The drains carrying agricultural fertilizers and insecticides, domestic solid and liquid waste, and industrial effluents join the rivers. The concentration of pollutants in rivers especially remains very high during the summer season when flow of water is low. The Central Pollution Control Board, in collaboration with state pollution control boards, has been monitoring water quality of national aquatic resources at 507 stations. The data obtained from these stations show that organic and bacterial contamination continues to be the main source of pollution in rivers. The Yamuna River is the most polluted river in the country between Delhi and Etawah. Other severely polluted rivers are the Sabarmati at Ahmedabad, the Gomti at Lucknow, the Kali, the Adyar, the Kum and Testraches, the Vaigai at Madurai, and the Musi of Hyderabad, and the Ganga at Kanpur and Varanasi. Groundwater pollution has occurred due to high concentrations of heavy or toxic metals, fluoride, and nitrates at different parts of the country. The legislative provisions such as the Water Prevention and Control of Pollution Act 1974 and Environment Protection Act 1986 have not been implemented effectively. The result is that in 1997, 251 polluting industries were located along the rivers and lakes. The Watersheds Act 1977, meant to reduce pollution, has also made marginal impacts. There is a strong need to generate public awareness about importance of water and impacts of water pollution. The public awareness and action can be very effective in reducing the pollutants from agricultural activities, domestic and industrial discharge. Recycle and reuse of water. Another way through which we can improve freshwater availability is by recycle and reuse. Use of water of lesser quality, such as reclaimed wastewater, would be an attractive option for industries for cooling and firefighting to reduce their water cost. Similarly, in urban areas, water after bathing and washing utensils can be reused for gardening. Water used for washing vehicles can also be used for gardening. This would conserve better quality of water for drinking purposes. Currently, recycling of water is practiced on a limited scale. However, there is enormous scope for replenishing water through recycling. Watershed management. Watershed management basically refers to efficient management and conservation of surface and groundwater resources. It involves prevention of runoff and storage and recharge of groundwater through various methods like percolation tanks, recharge wells, etc. However, in broad sense, watershed management includes conservation, regeneration, and judicious use of all resources, natural, like land, water, plants and animals, and human, within a watershed. Watershed management aims at bringing about balance between natural resources on the one hand and society on the other. The success of watershed development largely depends upon community participation. The central and state governments have initiated many watershed development and management programs in the country. Some of these are being implemented by non-governmental organizations also. Haryali is a watershed development project sponsored by the central government, which aims at enabling the rural population to conserve water for drinking, irrigation, fisheries, and afforestation. The project is being executed by Gram Panchayats with people's participation. Niru Water and Dew program in Andhra Pradesh and Arvari Pani Sansad in Alwar, Rajasthan have taken up construction of various water harvesting structures such as percolation tanks, dug out ponds, johad, check dams, etc. through people's participation. Tamil Nadu has made water harvesting structures in the houses compulsory. No building can be constructed without making structures for water harvesting. Watershed development projects in some areas have been successful in rejuvenating environment and economy. However, there are only a few success stories. In majority of cases, the program is still in its nascent stage. There is a need to generate awareness regarding benefits of watershed development and management among people in the country. And through this integrated water resource management approach, water availability can be ensured on sustainable basis. Rainwater harvesting. Rainwater harvesting is a method to capture and store rainwater for various uses. It is also used to recharge groundwater aquifers. It is a low-cost and eco-friendly technique for preserving every drop of water by guiding the rainwater to borewell pits and wells. Rainwater harvesting increases water availability, checks the declining groundwater table, improves the quality of groundwater through dilution of contaminants like fluoride and nitrates, prevents soil erosion and flooding, and arrests saltwater intrusion in coastal areas if used to recharge aquifers. Rainwater harvesting has been practiced through various methods by different communities in the country for a long time. Watershed development in Ralgan Siddhi, Ahmednagar, Maharashtra. A case study. Ralgan Siddhi is a small village in the district of Ahmednagar, Maharashtra. It has become an example of watershed development throughout the country. In 1975, this village was caught in a wave of poverty and illicit liquor trade. The transformation took place when a retired army personnel settled down in the village and took up the task of watershed development. He convinced villagers about the importance of family planning and voluntary labor, preventing open grazing, felling trees, and liquor prohibition. Voluntary labor was necessary to ensure minimum dependence on the government for financial aids. It socialized the cost of the projects, explained the activist. Even those who were working outside the village contributed to the development by committing a month's salary every year. Work began with the percolation tank constructed in the village. In 1975, the tank could not hold water. The embankment wall leaked. People voluntarily repaired the embankment. The 7 wells below it swelled with water in summer for the first time in the living memory of the people. The people reposed their faith in him and his visions. A youth group called Tarun Mandal was formed. The group worked to ban the dowry system, caste discrimination, and untouchability. Liquor distilling units were removed and prohibition imposed. Open grazing was completely banned with a new emphasis on stall feeding. The cultivation of water-intensive crops like sugarcane was banned. Crops such as pulses, oilseeds, and certain cash crops with low water requirements were encouraged. All elections to local bodies began to be held on the basis of consensus. It made the community leaders complete representatives of the people. A system of Nyaya Panchayats, informal courts, were also set up. Since then, no case has been referred to the police. A Rs 22 lakh school building was constructed using only the resources of the village. No donations were taken. Money, if needed, was borrowed and paid back. The villagers took pride in this self-reliance. A new system of sharing labor grew out of this infusion of pride and voluntary spirit. People volunteered to help each other in agricultural operation. Landless laborers also gained employment. Today, the village plans to buy land for them in adjoining villages. At present, water is adequate, agriculture is flourishing, though the use of fertilizers and pesticides is very high. The prosperity also brings the question of ability of the present generation to carry on the work after the leader of the movement who declared that the process of Dalgan's evolution to an ideal village will not stop. With changing times, people tend to evolve new ways. In future, railgun might present a different model to the country. What a mitigation approach can do, a success story. Traditional rainwater harvesting in rural areas is done by using surface storage bodies like lakes, ponds, irrigation tanks, etc. In Rajasthan, rainwater harvesting structures, locally known as kund or tanka, a covered underground tank, are constructed near or in the house or village to store harvested rainwater. See figure 6.5 to understand various ways of rainwater harvesting. There is a wide scope to use rainwater harvesting technique to conserve precious water resource. It can be done by harvesting rainwater on rooftops and open spaces. Harvesting rainwater also decreases the community dependence on groundwater for domestic use. Besides bridging the demand-supply gap, it can also save energy to pump groundwater as recharge leads to rise in groundwater table. These days, rainwater harvesting is being taken up on massive scale in many states in the country. Urban areas can especially benefit from rainwater harvesting as water demand has already outstripped supply in most of the cities and towns. Apart from the above mentioned factors, the issue desalination of water, particularly in coastal areas, and brackish water in arid and semi-arid areas. Transfer of water from water surplus areas to water deficit areas through interlinking of rivers can be important remedies for solving water problems in India. However, the most important issue from the point of view of individual users, households, and communities is pricing of water. Highlights of India's National Water Policy 2002. The National Water Policy 2002 stipulates water allocation priorities broadly in the following order: drinking water, irrigation, hydropower, navigation, industrial, and other uses. The policy stipulates progressive new approaches to water management. Key features include irrigation and multipurpose projects would invariably include drinking water component wherever there is no alternative source of drinking water. Providing drinking water to all human beings and animals should be the first priority. Measures should be taken to limit and regulate the exploitation of groundwater. Both surface and groundwater should be regularly monitored for quality. A phased program should be undertaken for improving water quality. The efficiency of utilization in all the diverse uses of water should be improved. Awareness of water as a scarce resource should be fostered. Conservation consciousness should be promoted through education, regulation, incentives and disincentives. और ये है इस चैप्टर का एक्सरसाइज। तो इसी के साथ हमारा ये चैप्टर ख़त्म होता है। तो क्योंकि ये चैप्टर छोटा था तो अभी हम नेक्स्ट चैप्टर शुरू करेंगे जो कि है चैप्टर 7 मिनरल एंड एनर्जी रिसोर्सेज। तो शुरू करते हैं हमारा ये चैप्टर। India is endowed with a rich variety of mineral resources due to its varied geological structure. Bulk of the valuable minerals are products of pre-Paleozoic age. Refer chapter 2 of class 11 textbook Fundamental of Physical Geography and are mainly associated with metamorphic and igneous rocks of the peninsular India. The vast alluvial plain tract of North India is devoid of minerals of economic use. The mineral resources provide the country with the necessary base for industrial development. In this chapter, we shall discuss the availability of various types of mineral and energy resources in the country. A mineral is a natural substance of organic or inorganic origin with definite chemical and physical properties. Types of mineral resources. On the basis of chemical and physical properties, minerals may be grouped under two main categories of metallics and non-metallics, which may further be classified as follows. Minerals, metallic mineral, non-metallic mineral. मेटालिक मिनरल के अंदर में आता है फेरस, एग्जाम्पल आयरन, मैंगनीज एक्सेट्रा, नॉन फेरस कॉपर, बॉक्साइट एक्सेट्रा। और नॉन मेटालिक मिनरल के अंदर में आता है फ्यूल मिनरल जैसे कि कोल, पेट्रोलियम, नेचुरल गैस एक्सेट्रा। और अदर नॉन मेटालिक्स एग्जाम्पल माइका, लाइमस्टोन, ग्रेफाइट एक्सेट्रा। As it is clear from the figure 7.1, metallic minerals are the sources of metals. Iron ore, copper, gold produce metal and are included in this category. Metallic minerals are further divided into ferrous and non-ferrous metallic minerals. Ferrous, as you know, refers to iron. All those minerals which have iron content are ferrous, such as iron ore itself, and those which do not have iron content are non-ferrous, such as copper, bauxite, etc. Non-metallic minerals are either organic in origin, such as fossil fuels, also known as mineral fuels, which are derived from the buried animal and plant life, such as coal and petroleum. Other type of non-metallic minerals are inorganic in origin, such as mica, limestone, and graphite, etc. Minerals have certain characteristics. These are unevenly distributed over space. There is inverse relationship in quality and quantity of minerals. That means good quality minerals are less in quantity as compared to low quality minerals. The third main characteristic is that all minerals are exhaustible over time. They take long to develop geologically and they cannot be replenished immediately at the time of need. Thus, they need to be conserved and not misused as they do not have the second crop. Agencies involved in the exploration of minerals. In India, systematic surveying, prospecting, and exploration for minerals is undertaken by the Geological Survey of India, Oil and Natural Gas Commission, Mineral Exploration Corporation Limited, National Mineral Development Corporation, Indian Bureau of Mines, Bharat Gold Mines Limited, Hindustan Copper Limited, National Aluminium Company Limited, and the Departments of Mining and Geology in various states. Distribution of minerals in India. Most of the metallic minerals in India occur in the peninsular plateau region in the old crystalline rocks. Over 97% of coal reserves occur in the valleys of Damodar, Son, Mahanadi, and Godavari. Petroleum reserves are located in the sedimentary basins of Assam, Gujarat, and Mumbai High, that means offshore region in the Arabian Sea. New reserves have been located in the Krishna, Godavari, and Kaveri basins. Most of the major mineral resources occur to the east of a line linking Mangaluru and Kanpur. Minerals are generally concentrated in three broad belts in India. There may be some sporadic occurrences here and there in isolated pockets. These belts are the northeastern plateau region. This belt covers Chota Nagpur, Jharkhand, Odisha Plateau, West Bengal, and parts of Chhattisgarh. Have you ever thought about the region of major iron and steel industry being located in this region? It has variety of minerals, viz. Iron ore, coal, manganese, bauxite, mica. The southwestern plateau region. This belt extends over Karnataka, Goa, and contiguous Tamil Nadu uplands and Kerala. This belt is rich in ferrous metals and bauxite. It also contains high-grade iron ore, manganese, and limestone. This belt packs in coal deposits except Neyveli lignite. This belt does not have as diversified mineral deposits as the northeastern belt. Kerala has deposits of monzite and thorium, bauxite clay. Goa has iron ore deposits. The northwestern region. This belt extends along Aravalli in Rajasthan and part of Gujarat, and minerals are associated with Tharavir system of rocks. Copper, zinc have been major minerals. Rajasthan is rich in building stones, that means sandstone, granite, marble. Gypsum and fuller's earth deposits are also extensive. Dolomite and limestone provide raw materials for cement industry. Gujarat is known for its petroleum deposits. You may be knowing that Gujarat and Rajasthan both have rich sources of salt. The Himalayan belt is another mineral belt where copper, lead, zinc, cobalt, and tungsten are known to occur. They occur on both the eastern and western parts. Assam Valley has mineral oil deposits. Beside oil resources are also found in offshore areas near Mumbai coast, Mumbai High. In the following pages, you will find the spectral pattern of some of the important minerals. Ferrous minerals. Ferrous minerals such as iron ore, manganese, chromite, etc. provide a strong base for the development of metallurgical industries. Our country is well placed in respect of ferrous minerals, both in reserves and production. Iron ore. India is endowed with fairly abundant resources of iron ore. It has the largest reserve of iron ore in Asia. The two main types of ore found in our country are hematite and magnetite. It has great demand in international market due to its superior quality. The iron ore mines occur in close proximity to the coal fields in the northeastern plateau region of the country, which adds to their advantage. The total reserves of iron ore in the country were about 20 billion tons in the year 2004 to 5. About 95% of total reserves of iron are located in the states of Odisha, Jharkhand, Chhattisgarh, Karnataka, Goa, Telangana, Andhra Pradesh, and Tamil Nadu. In Odisha, iron ore occurs in a series of hill ranges in Sundargarh, Mayurbhanj, and Jhar. The important mines are Guru Mahisani, Sulepet, Badampahar, Mayurbhanj, Kiruburu, Kendujhar, and Bonai, Sundargarh. Similar hill ranges, Jharkhand has some of the oldest iron ore mines and most of the iron and steel plants are located around them. Most of the important mines such as Noamundi and Gua are located in Purvi and Paschimi Singhbhum districts. This belt further extends to Durg, Dantewara and Bailadila. Dali and Rajhara in Durg are the important mines of iron ore in the country. In Karnataka, iron ore deposits occur in Sandhur Hospet area of Ballari district, Baba Budan Hills and Kudremukh in Chikmagaluru district and parts of Shivamoga, Chitradurg and Tumakuru districts. The districts of Chandrapur, Bhandara and Ratnagiri in Maharashtra, Karimnagar and Warangal in district of Telangana, Kurnool, Kudapa and Anantapur districts of Andhra Pradesh, Salem and Nilgiris district of Tamil Nadu are other iron mining regions. Goa has also emerged as an important producer of iron ore. Manganese. Manganese is an important raw material for smelting of iron ore and also used for manufacturing ferroalloys. Manganese deposits are found in almost all geological formation. However, it is mainly associated with Dharawar system. Odisha is the leading producer of manganese. Major mines in Odisha are located in the central part of the iron ore belt of India, particularly in Bonai, Kendujhar, Sundargarh, Gangpur, Koraput, Kalahandi and Bolangir. Karnataka is another major producer and here the mines are located in Dharwar, Ballari, Belgavi, North Kannada, Chikmagaluru, Shivamoga, Chitradurg and Tumakuru. Maharashtra is also an important producer of manganese which is mined in Nagpur, Bhandara and Ratnagiri districts. The disadvantages of these mines is that they are located far from steel plants. The manganese belt of Madhya Pradesh extends in a belt in Balaghat, Chindwara, Nimmar, Mandla and Jhabua district. Telangana, Goa and Jharkhand are other minor producers of manganese. Non-ferrous minerals. India is poorly endowed with non-ferrous metallic minerals except bauxite. Bauxite is the ore which is used in manufacturing of aluminum. Bauxite is found mainly in tertiary deposits and is associated with laterite rocks occurring extensively either on the plateau or hill ranges of peninsular India and also in the coastal tracts of the country. Odisha happens to be the largest producer of bauxite. Kalahandi and Sambalpur are the leading producers. The other two areas which have been increasing their production are Bolangir and Koraput. The peatlands of Jharkhand in Lohardaga have rich deposits. Gujarat, Chhattisgarh, Madhya Pradesh and Maharashtra are other major producers. Bhavnagar, Jamnagar in Gujarat have the major deposits. Chhattisgarh has bauxite deposits in Amarkantak Plateau, while Katni, Jabalpur area and Balaghat in MP have important deposits of bauxite. Kolaba, Thane, Ratnagiri, Satara, Pune and Kolhapur in Maharashtra are important producers. Tamil Nadu, Karnataka and Goa are minor producers of bauxite. Copper. Copper is an indispensable metal in the electrical industry for making wires, electric motors, transformers and generators. It is alloyable, malleable and ductile. It is also mixed with gold to provide strength to jewelry. The copper deposits mainly occur in Singhbhum district in Jharkhand, Balaghat district in Madhya Pradesh and Jhunjhunu and Alwar districts in Rajasthan. Minor producers of copper are Agni-Gundala in Guntur district, Andhra Pradesh, Chitradurg and Hassan district, Karnataka and South Arcot district, Tamil Nadu. Non-metallic minerals. Among the non-metallic minerals produced in India, mica is the important one. The other minerals extracted for local consumption are limestone, dolomite, and phosphate. Mica. Mica is mainly used in the electrical and electronic industries. It can be split into very thin sheets which are tough and flexible. Mica in India is produced in Jharkhand, Andhra Pradesh, Telangana, and Rajasthan, followed by Tamil Nadu, West Bengal, and Madhya Pradesh. In Jharkhand, high quality mica is obtained in a belt extending over a distance of about 150 km in length, about 22 km in width in lower Hazaribagh plateau. In Andhra Pradesh, Nellore district produces the best quality mica. In Rajasthan, mica belt extends for about 320 km from Jaipur through to Bhilwara and around Udaipur. Mica deposits also occur in Mysore and Hassan district of Karnataka, Coimbatore, Tiruchirappalli, Madurai, and Kanyakumari in Tamil Nadu, Alleppey in Kerala, Ratnagiri in Maharashtra, Purulia and Bankura in West Bengal. Energy resources. Mineral fuels are essential for generation of power required by agriculture, industry, transport, and other sectors of the economy. Mineral fuels like coal, petroleum, and natural gas, known as fossil fuels. Nuclear energy minerals are the conventional sources of energy. These conventional sources are exhaustible resources. Coal. Coal is one of the important minerals which is mainly used in the generation of thermal power and smelting of iron ore. Coal occurs, coal occurs in rock sequences mainly of two geological ages, namely Gondwana and Tertiary deposits. About 80% of the coal deposits in India is of bituminous type and is of non-cooking grade. The most important Gondwana coal fields of India are located in Damodar Valley. They lie in Jharkhand Bengal coal belt, and the important coal fields in this region are Raniganj, Jharia, Bokaro, Girit, Karanpura. Jharia is the largest coal field, followed by Raniganj. The other river valleys associated with coal are Godavari, Mahanadi, and so on. The most important coal mining centers are Singrauli in Madhya Pradesh. Part of Singrauli coalfields lie in Uttar Pradesh. Korba in Chhattisgarh, Talcher and Rampur in Odisha. Chandavadha, Kampiti and Pandir in Maharashtra, and Singarini in Telangana, and Pandur in Andhra Pradesh. At Singarani, canneries to miners rescue. Singarani Collieries, the country's premier coal production company, still uses canneries to detect the presence of deadly carbon monoxide in underground mines. Miners collapse and often die even if small quantities of the highly poisonous CO2 are present in the air. Though miners speak lovingly of the canneries, the underground experience is not at all pleasant for the birds. When lowered into mines the CO2 with CO presence, the birds show distress symptoms such as ruffling of feathers, pronounced chirping, and loss of life. These reactions occur even if 0.15% of CO is present in the air. If the content is 0.3%, the bird shows immediate distress and falls off its perch in 2 to 3 minutes. A case of burst is a good indicator in air containing more than 0.15% CO, said a coal miner. The sophisticated handheld CO detectors introduced by the company can detect CO concentration from as low as 10 ppm to as high as 1000 ppm. But despite this, the miners trust the birds, who have saved the lives of several of their predecessors. Tertiary coals occur in Assam, Arunachal Pradesh, Meghalaya, and Nagaland. It is extracted from Dharangiri, Cherrapunji, Meglong, and Langrin, Meghalaya, Makum, Jaipur, and Nazaria in Upper Assam, Namchik, Namphuk, Arunachal Pradesh, and Kalakot, Jammu and Kashmir. Besides, the brown coal or lignite occur in the coastal areas of Tamil Nadu, Pondicherry, Gujarat, and Jammu and Kashmir. Petroleum. Crude petroleum consists of hydrocarbons of liquid and gaseous states, varying in chemical composition, color, and specific gravity. It is an essential source of energy for all internal combustion engines in automobiles, railways, and aircraft. Its numerous byproducts are processed in petrochemical industries such as fertilizers, synthetic rubber, synthetic fiber, medicines, Vaseline, lubricants, wax, soap, and cosmetics. Do you know petroleum is referred to as liquid gold because of its scarcity and diversified uses? Indication of huge gas reserves in Ramanathapuram, Tamil Nadu. According to a newspaper report, The Hindu, 5/9/2006, the Oil and Natural Gas Commission has found potential zones of natural gas reserves in Ramanathapuram district. The survey is still in the initial stages, but the exact quantity of gas reserves will be known only after the completion of the survey. But the results are encouraging. Crude petroleum occurs in sedimentary rocks of the Tertiary period. Oil exploration and production was systematically taken off after the Oil and Natural Gas Commission was set up in 1956. Till then, the Digboi in Assam was the only oil producing region, but the scenario has changed after 1956. In recent years, new oil deposits have been found at the extreme western and eastern parts of the country. In Assam, Digboi, Naharkatia, and Moran are important oil producing areas. The major oil fields in Gujarat are Ankleshwar, Kalol, Mehsana, Navagam, Kosamba, and Lunaj. Mumbai High, which lies 160 km of Mumbai, was discovered in 1973 and production commenced in 1976. Oil and natural gas have been found in exploratory wells in Krishna Godavari and Kaveri basin on the east coast. Oil extracted from the wells is crude oil and contains many impurities. It cannot be used directly, it needs to be refined. There are two types of refineries in India. First, field-based, and second, market-based. Digboi is an example of field-based and Varuni is an example of market-based refinery. There are 21 refineries in India as on June 2011. Identify the states in which they are located. Natural gas. The Gas Authority of India Limited was set up in 1984 as a public sector undertaking to transport and market natural gas. It is obtained along with oil in all the oil fields, but exclusive reserves have been located along the eastern coast as well: Tamil Nadu, Odisha, and Andhra Pradesh, Tripura, Rajasthan, and offshore wells in Gujarat and Maharashtra. Non-conventional energy sources. Fossil fuel sources such as coal, petroleum, natural gas, and nuclear energy use exhaustible raw materials. Sustainable energy resources are only the renewable energy sources like solar, wind, hydro, geothermal, and biomass. These energy sources are more equitably distributed and environmental friendly. The non-conventional energy sources will provide more sustained, eco-friendly, cheaper energy after the initial cost is taken care of. Nuclear energy resources. Nuclear energy has emerged as a viable source in recent times. Important minerals used for generation of nuclear energy are uranium and thorium. Uranium deposits occur in the Dharwar rocks. Geographically, uranium ores are known to occur in several locations along the Singkum copper belt. It is also found in Udaipur, Alwar, and Jhunjhunu districts of Rajasthan, Durg district of Chhattisgarh, Bhandara district of Maharashtra, and Kullu district of Himachal Pradesh. Thorium is mainly obtained from monazite and ilmenite in the beach sands along the coast of Kerala and Tamil Nadu, whilst richest monazite deposits occur in Palakkad and Kollam districts of Kerala, near Visakhapatnam in Andhra Pradesh, and Mahanadi River Delta in Odisha. Atomic Energy Commission was established in 1948. progress could be made only after the establishment of the Atomic Energy Institute at Trombay in 1954, which was renamed as the Bhabha Atomic Research Center in 1967. The important nuclear power projects are Tarapur, Maharashtra, Ravatvarta near Kota, Rajasthan, Kalpakam, Tamil Nadu, Narora, Uttar Pradesh, Kaiga, Karnataka, and Kakrapara, Gujarat. Solar energy. Sun rays trapped in photovoltaic cells can be converted into energy, known as solar energy. The two effective processes considered to be very effective to tap solar energy are photovoltaics and solar thermal technology. Solar thermal technology has some relative advantages over all other non-renewable energy resources. It is cost competitive, environment friendly, and easy to construct. Solar energy is 7% more effective than coal or oil based plants and 10% more effective than nuclear plants. It is generally used more in appliances like heaters, crop dryers, cookers, etc. The western part of India has greater potential for the development of solar energy in Gujarat and Rajasthan. Wind energy. Wind energy is absolutely pollution free, inexhaustible source of energy. The mechanism of energy conservation from blowing wind is simple. The kinetic energy of wind through turbines is converted into electrical energy. The permanent wind systems such the trade winds, westerlies, and seasonal winds like monsoon have been used as source of energy. Besides this, local winds, land and sea breezes and can also be used to produce electricity. India already has started generating wind energy. It has an ambitious program to install 250 wind-driven turbines with a total capacity of 45 megawatts spread over 12 suitable locations, especially in coastal areas. The Ministry of Non-Conventional Sources of Energy is developing wind energy in India to lessen the burden of oil import bill. The country's potential of wind power generation exceeds 50,000 megawatts, of which one-fourth can be easily harnessed in Rajasthan, Gujarat, Maharashtra, and Karnataka. Favorable conditions for wind energy exist. Tidal and wave energy. Ocean currents are the storehouse of infinite energy. Since the beginning of 17th and 18th century, persistent efforts were made to create more efficient energy system from the ceaseless tidal waves and ocean currents. Large tidal waves are known to occur along the west coast of India. Hence, India has great potential for the development of tidal energy along the coast, but so far these have not yet been utilized. Geothermal energy. When the magma from the interior of the earth comes out on the surface, tremendous heat is released. This heat energy can successfully be tapped and converted to electrical energy. Apart from this, the hot water that gushes out through the geyser wells is also used in the generation of thermal energy. It is popularly known as geothermal energy. This energy is now considered to be one of the key energy sources which can be developed as an alternate source. The hot springs and geysers are being used since medieval period. In India, a geothermal energy plant has been commissioned at Manikaran in Himachal Pradesh. The first successful 1819 attempt to tap the underground heat was made in the city of Boise, Idaho, USA, where a hot water pipe network was built to give heat to the surrounding buildings. The plant is still working. Bioenergy. Bioenergy refers to energy derived from biological products, which includes agricultural residues, municipal, industrial, and other waste. Bioenergy is a potential source of energy conversion. It can be converted into electrical energy, heat energy, or gas for cooking. It will also process the waste and garbage and produce energy. This will improve economic life of rural areas in developing countries, reduce environmental pollution, enhance self-reliance, and reduce pressure on fuel wood. One such project converting municipal waste into energy is Okhla in Delhi. Conservation of mineral resources. The challenge of sustainable development requires integration of quest for economic development with environmental concerns. Traditional methods of resource use result into generating enormous quantity of waste as well as create other environmental problems. Hence, for sustainable development calls for the protection of resources for the future generations. There is an urgent need to conserve the resources. The alternative energy sources like solar power, wind, wave, geothermal energy are inexhaustible resources. These should be developed to replace the exhaustible resources. In case of metallic minerals, use of scrap metals will enable recycling of metals. Use of scrap is especially significant in metals like copper, lead, and zinc, in which India's reserves are immense. Use of substitutes for scarce metals may also reduce their consumption. Export of strategic and scarce minerals must be reduced so that the existing reserves may be used for a longer period. तो ये है इस चैप्टर का एक्सरसाइज और इसी के साथ हमारा ये चैप्टर ख़त्म होता है। तो आज के सेशन में हमने चैप्टर 6 और 7 कंप्लीट किया है। और अगर आप चैनल पर नए हैं तो चैनल को सब्सक्राइब कर दीजिए और नोटिफिकेशन आइकन पर क्लिक कर दीजिए ताकि आपको सारे वीडियो के नोटिफिकेशन मिल सके। और अगर आपको वीडियो अच्छा लगे तो लाइक कर दीजिए, साथ ही अपने दोस्तों के साथ शेयर करिए ताकि उन्हें भी हेल्प हो सके। तो हमारा ये वीडियो यहीं तक था। थैंक यू, थैंक्स फॉर वॉचिंग।